HPLC stands for High Performance Liquid Chromatography. This is a technique used to separate, identify, and quantify compounds from a mixture. This technique is based on the use of two phases, stationary and mobile phase, and the different physicochemical characteristics between them. The type of separation mechanisms are classified according to characteristics such as ion exchange, molecule size, affinity, and polarity. There are two kinds of HPLC, normal and reverse phase. Reverse phase chromatography is the most common. Here, the stationary phase is non-polar and the mobile phase is more polar than the first phase. The materials most frequently employed are silica-based as the stationary phase and water with organic modifier as mobile phase. The separation and identification of the compounds is due to the retention time of each compound, and it is based in their polarity. With a high polarity in the mobile phase, there is an increase in the retention time of non-polar analytes. Despite the column is a true heart of HPLC, obtaining data wouldn't be possible without a suitable detector. Detectors output a signal as a function of the compound's concentration. There are several detectors for we can choose, according to the noise level, sensitivity, selectivity, or the needed wavelength. The UV-vis absorbance detector is probably the most popular and can be further divided into three types: single or variable wavelength and UV detectors that provide spectra information such as diode array detector, also known as DAD. DAD is useful in HPLC because it allows the identification of samples and it also provides qualitative information. DAD has two main advantages. First, it gives us the opportunity to select the best wavelength for our analysis. And second, it allows a better compound identification in impure samples. But how does a diode array detector work? A diode array is an assembly of 1024 individual photodiodes in a linear array, detecting absorption in UV-vis region. Thanks to this array, DAD can detect more than one wavelength at one time. This happens because the light from the lamps is shone directly onto the flow cell. Then, the light that passes through the flow cell is dispersed by the diffraction grating, and the amount of the dispersed light is estimated for each wavelength in the photodiode arrays. The Agilent 1200 series is a HPLC system coupled to a diode array detector. This system consists of a vacuum degasser, a binary pump, an autosampler, a thermostated column compartment, and a diode array detector. In Campus Querétaro, this equipment is used mainly for the analysis of phytochemicals. We would like to share with you one of the current applications of this system. Meet Anna, a master's student. Her research is about finding the compound responsible for the hypoglycemic activity of fruta extracts. First, using dried ground leaves, she prepares extracts employing methanol, a polar molecule, as a solvent. After maceration and filtration, the solution is concentrated using a rotary evaporator. And just like that, extract is ready to be inserted into vials. So, what's next? Well, Anna is looking for a special kind of phytochemicals called flavonoids, which are polar. For this reason, she must also insert her own standardized solution of flavonoids. In this case, she will use quercetin and rutin. She must have replicas to improve the accuracy of her experiment. For this method, Anna has to create a concentration gradient in her mobile phase. For this, she prepares two solutions, phosphoric acid and acetonitril in distinct proportions. With all the materials prepared, we are now ready to create a program for our method. The Agilent software for the system is quite friendly. We pick the injection volume and the flux over time periods of each pump to create a concentration gradient. The software informs us that HPLC is ready to go. In the autosampler, a needle erupts the cover of the vials, takes a teeny tiny sample, and the magic starts. Now, it is time to let the HPLC system do its job. We go away and wait.
2 horas más tarde.
We have results. Here, we can see the peaks corresponding to quercetin and rutin. And this is the resulting chromatogram for the ruta extract. This confirms the presence of these flavonoids in the plant. Now, Anna can try to prove that they have hypoglycemic activity. Stay tuned if you want to know how it goes. Thank you for your attention.
Coming up next.
Fatality.